Hi, ladies. We're down here to the last B day before spring break, and never could have predicted we would be at this situation right now, but here we are. So let's get started. Today, prayer update, no prime time. We'll review homework questions from your book, classwork answers, do a little bit of content, only one little new thing, and talk about what you might want to consider doing over break and looking ahead. So let's start in prayer. In the name of the Father, the Son, and the Holy Spirit. Amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen. So I see a number of you have added some intentions to our Google Doc for the classroom. So please keep on using that. And definitely a lot of concerns for family members and people in our community, as well as individuals that we may not even know, such as nurses and doctors. So please feel free to keep on adding to that prayer request, and we'll keep on thinking about those people as we go through the coming weeks. So class update. The tests, I've finished grading all the one-pagers, and they really do look very good, and I think these are the best ones you guys have done all year. Many good things I saw on them. I emailed you if there was any issue, like it wouldn't download, I didn't have it, I only had one but not the other. So if you didn't receive an email from me, that means that everything was good and I have graded it. I haven't started grading the photo assignment. I've downloaded them all. I've set up the rubric to grade them. I've printed all 48 of those rubrics out. So I'm getting ready to do that, but I haven't actually started grading on them. I wanted to get today's video done first. So the rest of your grading in progress, I'll email when everything is graded and posted. I'll send out the rubrics to you for the curation as well as the test. And I will send that all out to you as soon as I get it all done. I've been responding to emails. I spent about 5 hours yesterday replying to emails, entering grades from emails. So thank you guys for being patient with me. I'm doing the best I can. And this distance learning, while it's time consuming for you, it is a lot more time consuming for me. And being part-time is already kind of crazy. Right now, your teachers who are full-time and have multiple preps, I really have no idea how they do it. So thank you guys for being patient. Really appreciate it. I am adding comments on PowerSchool on any grade when I can't read a file or there was no submission on PowerSchool, or if the document submitted was really something else. I've gotten a few other random assignments from like algebra and religion and a few other things. So take a look at the comments before you email me saying, why did I get a 0? Because chances are the comments in there should tell you. Once I've graded it, I have really no way of seeing that you submitted another document or something else for the grade. The best way to let me know is to email me saying, I resubmitted to PowerSchool this item, and I can go into PowerSchool, look at it. That's fine. But PowerSchool doesn't come up and tell me that somebody sent in an assignment that was missing previously. Let's see here. Last time I talked about the Kami, which is the free add-on to Chrome, and looking at some homeworks, it looks like quite a few people have been using that. Just know that'll work really well for some things. For others, it won't work so well because there's a few things that you're really going to need paper copies of. So use it as much as you can. At least it's free for now. I don't know how long they'll keep it open and keep it for free. I was looking at it. I think it was like $100 for me to get it and then allow my students to use it. And there were classroom or school accounts that you could get. So I think right now, as long as it's free, let's just keep on using it. Future schooling, packets and mailing. I've printed out chapter 4 packets. I'm assembling chapter 5 and 6. 6 is really, 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 really short. So I'm working on that. If you sent me your street address and zip code, I've got that pretty much already ready, and I will email you when those packets go in the mail. I don't know if I'll have them out Friday. I'd like to, but I definitely will have them out no later than next Monday. So you will definitely have them by the time you're done with spring break. So, personal update. Some of the things from our trip to Palau, I told you last time a little bit about some of the war stuff that was there. And this was really rather interesting and kind of amazing to me that we'd never even heard of this before, but that I think is part of our society and our studies of World War II. We really focus a lot on the European portion and less on the Asian portion or Pacific portion. So this on the island that I showed you the other pictures on, this is Peleliu. There is this cave, there's actually a mountain ridge in the middle of the island, and it runs quite a long ways. And you can kind of see it here. There's this hole in the trees. That is actually an entrance to a cavern system that was built by the Japanese for them to hide out because they knew the Americans were coming and they were going to invade the island. So they built this thing. It says it's 1,000-man cave. I don't remember how many rooms it has. I think it was like 33 rooms in this cave system that they were living and hanging out. And as the Americans came in and they were trying to retake the island, the Japanese waited until they got midway down the ridge of the island, and they started attacking them from the front, the side, and behind. And the Americans were really caught in a very, very difficult battle. It's kind of interesting. You can kind of see there's like debris here on the floor, and there were lots and lots of bottles and bottle caps and ammunition cartridges. These are actually, I was told by the guide, these are still there from the war. They never cleaned it up. They never did anything with it. It is all still sitting there, and these are supposedly still actual artifacts from the war. And in this area, there were a bunch of bats. The tour guide gave us the option, if we were a little squeamish, we could turn around at that point and go back out the same place we entered, or if we weren't really bothered by them, we could go by and see the bats. So there were a bunch of bats hanging out in the cave, which is kind of a normal thing. So that was very interesting to see this cavern system that they had built, and the intelligence that the Allies had. They had no idea that the Japanese had done this. So it completely took them by surprise. So this is a couple other pictures on the island. So this is the beach that was invaded. It's called Orange Beach, and it was invaded on Peleliu. A memorial to the people who lost their lives here, and some pictures of some flowers that were kind of around this memorial area, a plaque to soldiers who were there. It was really interesting and really a beautiful place, and kind of hard to imagine the wartime effort that had gone on there. So another part of my personal update is about our dogs. So we're still working on training them. They're kind of giving us some attitude, actually, and not wanting to do what they're supposed to. And our trainer's like, you guys have to be firmer. You have to be a little sterner. So we're kind of working on that. But in the meantime, Carmel has another skin infection. And some of you may know that we battled this last year for about 9 months. And it was, I think, 5 different antibiotics that we ended up putting her on. They cultured it 3 times and it was resistant to everything. And we noticed on Friday that she was starting to get some sores under her one arm paw pit, her front one, and took her to the vet on Saturday, started the antibiotics again. They're kind of intense because we have to handle them with gloves. So they're fine for the dogs, but I guess they absorb through human skin. And so, you know, it's like sometimes it feels like if it isn't one thing, it's about 50. And it seems like there's just one more thing all the time here. So life is always interesting, but otherwise things are going just fine. So on to your content for the day. So chapter 4 topics. We're going to be kind of wrapping up formulas for today and atomic theory. I will reflect back on it on our first day when we get back together after spring break. And don't worry too terribly much about the chemical formulas part. If you do have questions, please definitely put it in the survey. But I will be going over that again, and we will do a lot more of that as we go into balancing chemical equations. But I wanted to introduce it now so you have a little bit of exposure to it when we get there. So the other topics we'll really be covering after spring break. So your homework answers to 4.1 and 4.3, go ahead and pause it. I don't think there's anything in here that's going to be surprising or hard. Answers to the ancient chemistry video questions. Again, pause it, see if there's anything in here that was surprising. I think it's pretty much word for word from the video. And lastly, answers to questions from the Ernest Rutherford video. Not a whole lot here that should be surprising. So practice on your green page 9 that you may have just printed out this one, or you may have just done it in Kami. So reading chemical formulas. So I got a few questions, and when I was glancing at homework that was turned in, I see that there were a few that weren't, that there were questions on or ones that were wrong. So specifically, I want to look at number 5. So number 5, Na2CO3. Remember, Na is the symbol for sodium. So there are 2 sodiums. Here there's 1 carbon. If there's no subscript, it means that it is implied to be a 1. And then there are 3 oxygens. Number 7. Okay, so calcium, there is 1 of those. Hydrogen, there are 2 listed here, but there's a 2 outside the parentheses, which means that there are 2 of this whole H2PO4 molecule. It's an ion that's binding to calcium. So that means there's 2 times 2, which is 4. Phosphorus, there's 1, and then you've got a 2 because of the parentheses, so that ends up being 2. And then the oxygen, there are 4, but again, there are 2 of these entire molecules, so you've got 8. 2 times 4 is 8. Then number 14, there's a lot going on here. So we have Fe2, and the 2 in the front, the coefficient, means that there's 2 of this entire Fe2SO43 molecule. So that means instead of just 2 irons, there's 2 times 2, which is 4. Sulfur, there's 1 here, and then there's 3 of those, so that would be 3, and then you multiply it by 2, and you get 6. And as far as order of operations go, when you multiply 3 times 2, or whether it's 2 times 3, it isn't going to matter. However, in some of the other molecules, you'll find that it'll be important to do the subscripts and the parentheses first before you go and do the coefficient at the end. Okay, so sulfur, there's 1, so 3 times 2, I did that one. Oxygen, there's 4, and then you multiply it by 3, so you get 12. And then you multiply the whole thing by 2 and get 24. Then number 17. Okay, 17. 2 aluminums multiplied by 3 is 6. 2 silicons multiplied by 2. 2 times 3 is 6. Oxygen. Okay, we have an oxygen here. There's 5 of them. And we have an oxygen here, which there are 4 of them. So there are 5 plus 4, which is 9. And then you're going to multiply that by 3. Because remember, this ends up looking like Al2, Si2, O5, OH, 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 OH. So you end up with 4 of these OH groups. So again, oxygen, you've got 5 of them here. You're going to have 4 of them between here in the parentheses. 5 plus 4 is 9. Times 3 is going to be 27. Hydrogen, there are 4 of them, and you multiply it by 3 and you get 12. Then number 20, looking at it, we've got a nitrogen here, we've got one here. So nitrogen, there's one of these with the 3 subscript, so that's 3. And then one more here is 4. 4 times the 2 in front is 8. Hydrogen, there are 4, and then we have 3 of those groups, so there's 12. 4 times 3 is 12. Times 2 in the front is 24. Hopefully that answered most of your questions on that. All right, so development of atomic theory, we're going to continue on with watching one more video about Niels Bohr. There is another set of questions, and so if you don't have those, I did upload them as both a doc file and a PDF, so you should have either one and you can watch the video and record in the document. So if you don't have it handy, you probably want to get it.
Heisenberg, Schrödinger.
I'm going to back it up for a sec.
Among the science luminaries at their height in the revolutionary early 20th century, Einstein, Heisenberg, Schrödinger, was Niels Bohr, a physicist who redefined how we think about atoms and electrons and enabled chemistry to make a quantum leap into the modern world. Niels Bohr was born in Copenhagen, Denmark in 1885. His family was nerdy. Bohr's father was a university professor who was nominated for Nobel Prizes, while his sister became a teacher and his brother was a mathematician. 2 of Bohr's own sons grew up to be scientists as well, and one of them, Olga, won a Nobel Prize in physics. Talk about your family traditions. As a kid, Niels liked to tinker, fixing watches and bicycles. In high school, Bohr gravitated to physics and bonded with chemistry. He was a prodigy, finding errors in his textbooks. In college, he was apparently known not just for his brilliance, but also for his habit of breaking glassware and blowing things up in the chemistry lab. He once set a record for most broken glass in one semester. Where Bohr really made his mark wasn't in the lab, though. As he moved through graduate school, Bohr became more and more interested in theoretical work, the stuff of equations more than Erlenmeyer's. He left Copenhagen for England, where he worked with some of the top chemists and physicists of the day, like J.J. Thomson, who discovered the electron, and Ernest Rutherford, who was figuring out what makes up atoms. Rutherford's famous gold foil experiment proved that atoms had a small, dense, positively charged core, seemingly surrounded by lots of empty space. Based on that idea, Rutherford theorized that atoms had a nucleus at the center and electrons whizzing around it, kind of like planets around a star. Bohr spent just a few months with Rutherford, but on his return to Denmark, he started working out the theories he's remembered. In 3 papers known as the Trilogy, Bohr showed that the electrons in Rutherford's model had to be at fixed distances from the nucleus. Bohr's theory was based on recent research in physics by the German genius Max Planck, among others, that showed energy could only move in specific amounts, or quanta. You know, that's the plural of quantum. This was a revolutionary idea compared to classical physics that Newton and others forged out, where balls flying through the air arc in a continuous path, just like planets moving around a star. Note, in quantum theory, particles can only exist in specific places where the energies are allowed, which seemed, well, weird. Bohr adapted this quantum thinking to the atom, showing that electrons fit into different energy levels. The electrons could jump between these energy levels, moving to a higher one by absorbing a fixed amount of energy, or moving to a lower one by releasing that fixed amount of energy in the process. At first, other scientists didn't think the idea of energy levels made any sense, but it was incredibly good at correctly predicting natural phenomena, unlike models that came before it. Take the characteristic spectrum hydrogen produces when it's electrified. These lines have been described experimentally, but no one was sure why they appeared where they did. It was only when Bohr applied his theory of energy levels to it that he could explain how each line corresponded to an electron moving between energy levels, but never in the middle. Atomic spectra had been a map of how the atom works all along, but no one knew how to read it before Bohr. For building this eminent understanding upon the strong foundation of Planck, Bohr received the 1922 Nobel Prize for his atomic model. Planck had gotten one 4 years before in 1918. But this was hardly the end of this Great Dane's scientific career. It was an incredibly rich and dynamic time in physics. Bohr discussed the latest theories and discoveries with Erwin Schrödinger, Werner Heisenberg, and Albert Einstein. And later in his life, Bohr came to accept the evidence for a universe based largely on the rules of probability and quantum mechanics. Ironically, as he and others came to understand this reality, a newer theory of the atom emerged and replaced Bohr's as well. After all, his model turned out to only really work for hydrogen, not so much for the rest of the periodic table. But the atomic model theories that replaced Bohr's would not have been possible without his clearly showing quantum mechanics had to be incorporated. It was also a dangerous time in Europe. As the Nazis gained power in Germany, Bohr helped scientists there flee to institutions around the world. But when Hitler invaded Denmark in 1940, Bohr famously thought to dissolve the gold Nobel Prize medals of two colleagues in acid so they couldn't be stolen. They sat in a jar on a shelf until after the war, when the gold was recovered and the medals remade. Bohr himself fled to Sweden because of his mother's Jewish roots. Before leaving Sweden for England, Bohr met with the king about the plight of Denmark's Jews. Shortly thereafter, the Swedish government helped organize a massive rescue of thousands of Danish Jews.
So pretty interesting guy, and
luminaries at their height in the
hopefully you were able to catch most of the answers to the questions on that. And I think the information in that video is pretty cool, interesting to know about his time during the war and melting down his Nobel Prize medals, which is kind of sad, but I guess understandable. So, switching topics, chemical formulas. Just to remind you, if you didn't catch it as I was going over some of your homework. So, subscripts go along with the formula for a molecule. The subscripts are part of telling you what's in that molecule. So, you have here B2O3, a molecule that needs 2 borons and 3 oxygens in order for it to be a molecule, and it has that chemical formula. The 3 in the front tells you that there are 3 of these molecules. So when you're going and trying to count atoms and figure out how many there are of each particular type in any molecule, you want to first figure out how many are there in the molecule and how many molecules do you have. So some more practice for you to do on that is in this green packet, page 12, coloring sheet. I don't know how well this will work on Cami. I have not done any coloring on it, so I can't tell you how well this will work. For those of you who can print it, I do recommend you printing it and then coloring this shape in. For those of you who do not have a printer, you can wait until you get the packets from me and then submit it. So there's 4 parts to this. So this first one says, find the chemical symbol for each element, color shapes in red. And so you're going to have the symbol here, and most of these you should probably know. There's a few that you might not know, and you might need to look at your periodic table. Down here, find the number of hydrogen atoms. Remember, it's only asking for how many hydrogens. And then you're going to color in those corresponding shapes in blue with however many hydrogens there are. The next section is carbon atoms, and you're going to color those in yellow. And in the last one, you're going to find the total number of atoms in each molecule. So for example, this one is Na3PO4. So you've got 3 sodiums, 1 phosphorus, and 4 oxygen. So 3 plus 1 plus 4 would be 8. So you're going to end up filling in the shape up here that has the number 8 in black. You do kind of want to stick to those colors because the picture will should make a little bit more sense. So feel free to pause it if you want, or come back and work on this at the end. So right now is where I typically introduce polyatomic ions because we're heading into spring break, and I normally introduce them either the day before or 2 days before we head on break, because we need to memorize our polyatomic ions, and by the time we get back from spring break, there's enough going on, and a lot of people would like a little bit more time for memorizing those. That being said, this year being such an odd year and how we're going to work the rest of the school year, I don't know how likely it is to be seeing you. But if I was seeing you, I would be giving you short polyatomic ion quizzes after we return from spring break. But I am going to still encourage you strongly to work on memorizing them because they will really be helpful next year, and it will be required next year for you to have them memorized. So what I normally do is hand out this sheet, and I will post this up on P-Learning. And this is kind of an introduction and an explanation about it. And you don't have to worry about understanding the explanation now because I will talk about that later. But as far as memorizing the polyatomic ions, the ones that are really important are to memorize the ones that have an 8 ending, ATE, and those are all highlighted in or yellow, and the ones that are in green, and they're very individual, they're not in a series. So the ones that end in 8 have an ite with the same beginning, so it's chlorate. You've also got chlorite, you've got hypochlorite, and you also have a perchlorate. And there are rules for understanding these and how to figure them out. But if you start with memorizing the chlorate, you can reason out all the other ones. The same is true with all of these other ones that you have here, which is why I say the ones you really need to memorize are the ones that end in 8. So in the past, I didn't have a good way of memorizing this, and I had a student who found a video that was really helpful. So I'm going to kind of show part of that video, and I'm also going to put the link in this doc up on PowerSchool. So very briefly, what you're going to do is you're going to start by memorizing the ones that have the 8 ending, which are listed here, and the ones with the special names. So somebody came up with this mnemonic device to try to help memorize the ones that have the 8 ending. And that is this: Nick the baby camel ate an inch clam and crepes for supper in Phoenix. However, the person who posted this video is going to do it in a much better way and much shorter than I can do it. So we are going to go ahead and start with watching what she has to say.
Hi guys, Ms. Marusik here, and today I want to talk to y'all about memorizing polyatomic ions. Now, polyatomic ions are ions where we have several elements together that have either lost or gained some electrons, and so they have a charge. And you can see some of the ones that we're going to make you memorize here on this list, and you can see that it's got 2 different symbols here, two different elements. Some of the elements have a subscript with it, and then we have a charge that shows, like, for example, here with a negative charge, that we gain some electrons. Now, these are one of those things that are really tricky for students to memorize just because they seem totally random. They won't be random eventually, especially when we learn to name and write formulas of compounds. But for now, it just seems like we're having you memorize random stuff. So I want to kind of give you some tips and tricks that you can use to help yourself try and get used to memorizing these. Now, I'm going to show you a trick that works for the 8s. Okay, and you notice the 8s all end with the 8 name. So we'll talk about some of these other ones here in just a little bit, but I want to talk about the trick first. And you see I have some really random looking clip art pictures here. I've got a camel, I've got a clam that has an inch measurement above it, I've got some crepes, makes me hungry here, and then a phoenix sign, and you're like, what the heck do these have to do with polyatomic ions? Well, I'm going to write down a saying that you can use for the 8 polyatomic ions, okay, for the ones that have 8 at the end. So here's the saying. Nick, the baby camel, ate an inch clam and crepes for supper in Phoenix. So again, Nick the baby camel ate an inch clam and crepes for supper in Phoenix. Now, let me show you how this works, okay? If you remember us looking at that list just a minute ago, all of our polyatomic ions had a first symbol to it, and then an oxygen with it, and then a certain number of oxygens with the charge. So how this works is the first letter of each of these main words here help us to know what element goes at the front. So like, for example, this one is for nitrogen, okay? And we're going to put some oxygens with it. So Nick is for nitrate polyatomic ion. And what I want to do is I want to put how many oxygens and the charge of that nitrate. So how it works, the consonants, N, C, and K, 3 of them. That tells you your number of oxygens. Now, your charge comes from how many vowels you have in it. Okay, so like for example, here I have 1 vowel, so that means I have a -1 charge. Now, you could write just negative if it's -1, or you could write -1 like that. Or some teachers are really particular about you putting 1 negative, especially if you're taking AP or IB, because some books accept that as more proper format. I'm okay with you putting -1, but you may want to kind of double check and make sure with your teacher what they prefer you to put. All right, so there's for nitrate. Baby is for bromate. So I have BRO, okay? I have 1, 2, 3 consonants. We're going to go with Y being a consonant here. And 1 vowel, -1. Okay. Now, there are 3 of these that all start with C. So we kind of have to be careful which one is for which. We have carbonate, we have chlorate, and we have chromate. Now, camel is going to be for carbonate, which starts with carbon. We have oxygens in it. We have specifically 1, 2, 3 consonants, so we have 3 oxygens. And then we have 1, 2 vowels, so that's going to be a -2 charge there. Now, these are kind of what I like to call filler words, but actually the 8 is kind of helpful because that reminds us that these are all for the 8 polyatomic ions, okay? Inch is for iodate. So I'm going to have my iodine, okay? I have O's. I have 1, 2, 3 O's for the 3 consonants. And then I have a -1 vowel, okay? Clam is for chlorate. So I have ClO for the chlorine and the oxygens. And then I have 1, 2, 3 consonants and 1 vowel, -1. Okay. Crepes is for chromate. Okay. Now, chromate has chromium in it. And we have oxygen. And we have 1, 2, 3, 4 consonants and 1, 2 vowels of -2. Okay. So now, supper. Now we're getting to some long ones, right? Supper is for sulfate. Okay, so we have S and O, so sulfur and oxygen. We have 1, 2, 3, 4 consonants and 1, 2 vowels, so -2. And then finally, Phoenix. Now, a hard city to spell, so you got to kind of be careful here with the spelling. But it stands for phosphate. So that starts with phosphorus. We have oxygens. We have 1, 2, 3, 4 oxygens, and 1, 2, 3 vowels for our charge of -3. Now, like I said, this works for the 8s. But there were more on that sheet that we gave you, and so you kind of have to make sure you know how to get to the other ones. But for the 8s, this is super helpful to figure out those consonants in charge. So let me go back here for just a minute to our chart that we were looking at before.
So for what we're doing for right now, that is going to help you get through memorizing the 8s. So you do need to know the formula with the subscripts and the charge up here. So that should hopefully help you. And as time goes on, you should get better and better and then kind of have these memorized because you will be utilizing these quite a bit. A little bit more this year, but a lot next year. And you'll need to recognize the name of the ions. So a comment about the ones with the special names. So ammonium is the only positively charged ion in all of the ones we're going to actually work with. So it is +1. It is the only one that is positive. You've got a few other ones here. You've got acetate, which does have an ATE ending. It just doesn't happen to fit in with the rule on the video that we just watched. Permanganate is actually manganate with the per suffix at the beginning. However, we don't have a lot of use for manganate, so the only one we're really going to be using is permanganate. And it's actually purple and it's kind of neat. So these are the ones that I would have you work on trying to memorize. Now, is it absolutely required, and are we going to have quizzes that are online? I don't see how that's really reasonable or going to happen. However, I will say that it will be very useful to you to try to spend a little bit of time attempting to become familiar with these. If you can memorize them, it is going to be really helpful to you later on as we're naming compounds and as well next year. It actually will be vital next year. So I have a little write-up here which kind of explains what the person in the video was talking about. However, I think the video is really useful in being able to grasp this whole idea of counting the consonants and counting the vowels. And that is the best explanation that I have found. So turn in work, due Friday. So I really don't want you guys to have to be doing much over spring break and not really assigning homework. So the only things you've got are turn in these video questions on the Niels Bohr video and do the reveal the image, elements, and molecules. So for those who can't print, just wait until you get the paper copy. You can try it on Kami. I don't know how easy it'll be. For those who can print, just go ahead and do it before break and be done with it. I will have a survey up online again. I don't have it finalized. I have a number of additional questions that I'm going to be asking you, kind of about some things in the past that I need to work on, things moving forward. So it's a little bit more detailed, and I just didn't get it all done before I was recording the video. I do have a number of questions that I wanted to go over and answer that I have not done in class yet. So question, will the answers to the optional homework still be posted to check our answers? Definitely. So I will be posting those answers to 4.4 and 4.5 on PowerSchool. So those will be up there. And I can still answer any questions that you might have. So these answers will be up on PowerSchool later on. How long do I think this COVID-19 will last? Because I think nothing's going to change. And what if this continues and we spend beginning of junior year at home? I don't know how long it's going to last. I fully anticipate we're not going back to school during this school year. How long is it going to last? I don't know. I think there's so many unknowns and everything is changing so fast and so quickly that I think it's really hard to predict. mean, I couldn't have predicted 3 weeks ago that we would be in this situation. So I think until we see what the numbers are like, how many infections we're getting, how our hospitals are doing, and when we've kind of hit the peak, I don't know that we know how long this is going to go on. It is definitely a scary time and a challenging time. So all we can do right now is to do the best we can. And I wish I had a better answer for you guys, but I don't. If in-school classes are canceled for the rest of the year and we have to finish with online, will we still take finals? I have no idea what administration is planning. Seeing that your final was starting out as 20% of your grade, I'm not exactly sure what we're going to do. There are some students who have Fs for the third quarter, and right now, very limited options to bring those grades up. So I think we've got to do something in order to accommodate the fact that students who failed the third quarter or didn't have the grades that they wanted the third quarter, we've got to find a way to do something to make it work. But officially, I've received nothing from administration to tell us how that is going to work. So why is it that the Romans came up with a very advanced system for indoor plumbing, but yet centuries later, Europe regressed and used a much outdated and less advanced and efficient plumbing system? Really good question, because some people don't carry that knowledge around. You know, you've probably heard the saying about those who don't know history are bound to duplicate it. I think that we see again and again through time, and knowledge is lost. Scientific knowledge is significantly lost. In the Arabian Peninsula, there were very sophisticated math and ideas that were going on, and that was kind of lost in our European background. They didn't trade those ideas and that sophisticated math, and it took a long time for Europeans to catch up. So I think as time goes on and there's more sharing of ideas and sharing of information, we tend to not lose some of that. But I do think some of our technology issues and things that are going on, we can see it now about, what countries are helping each other with trying to come up with viruses or antidotes to the virus and vaccines and treatments and all of that, and the places in the world where they're not sharing. So part of that is a cultural thing. Think I answered most of the other questions. I did get asked by a couple people, can we spend more time on chemical formulas? Yes, most definitely, we will do that. Hopefully the sheet today was not too hard and you should be okay with that. I will go over some more. I have a couple of activities that I normally do in class and I can't really do those here, so I'm looking for some alternatives. I will come up with something, particularly for the first day when we come back, because everybody should have the green packet. And if I can find some other activities, I will do that. And I'm hoping to have some task cards or something like that. I've seen some people doing those digitally, but I have no idea how to make that work. So I will come up with a few more things to do some more practice on those formulas. And yes, we will work on them again, and because we are going to use them to balance chemical reaction equations. So I think that was everything that I got on questions. So over break, consider memorizing the polyatomic ions as discussed in today's video. Again, it's not required. I can't necessarily quiz you in the way I would in school because we're just not together. But again, I really encourage you guys to try to do it. It will help you out so much, and it will be necessary next year. Printing the green packet and other handouts posted on P-Learning. I am going to keep on getting the other packets and other things together. And like I said, there's a few resources that I normally do in class with some things that I hand out, and they're already cut apart and things. I don't know how to make some of that work. So I will continue posting things up on P-Learning that you can print out. So I will clear out all the stuff on the distance learning page, put it all into the archive, and only leave the things that are there for printing out or checking the most recent homework. And the last thing is I talked last time about getting candies to use. after break, as I talked about, because we're going to use them to represent protons, neutrons, and electrons. You won't need those on day 1 when we get back, but you will probably be using those on day 2, 3, and moving forward. So if you have some candies that you can set aside, 3 different colors, small candies are going to be useful because you're going to be using them on a sheet of paper. That'll be most helpful to you. So there really isn't going to be any homework. I'm not assigning book reading. I will be posting on P-Learning the sections and the questions that would go with the sections for anybody who does want to have them, because I will just kind of get that up to date as I kind of work my way through the rest of the chapter and what I'm going to do and how I'm modifying it for this whole distance learning thing. So ladies, it's always a pleasure, and I am going to set up a meet for Thursday. I think it'll be really useful to go ahead and get together and chat with you guys. I've missed seeing your faces. I've missed having a chance to talk. I really hope that you guys have a nice spring break, a wonderful Easter, and that I know there's an awful lot of family time, and sometimes that's a little challenging. And I've read some of your comments, you know, you're kind of ready to see some people other than your family and kind of get away from that. So I totally get that. But ladies, know that you're missed, and I miss seeing you guys, and I really am looking forward to having an opportunity to see everyone whenever we can get back together. Thanks for working so hard. Again, your tests were awesome. So proud of you guys. You've done amazing. I think if I were in your shoes, I wouldn't have done half as well as you guys have done. So kudos to all of you. And now we have a well-deserved break. So I hope you have a fantastic week, and we'll be in touch. So ladies, take care. Oh, wait, one more thing. After break, we'll use the green packet and review everything, and we're going to finally get to atoms. And I'm working on trying math videos. I will email rubrics and need the candies. So I guess the only thing really new there was that we're finally going to talk about atoms and electrons and protons and neutrons. So again, ladies, great job. You have a well-deserved spring break. Relax, enjoy, do some fun things, be creative, and I will talk to you in a week and a half.